This is the Spokane .NET user group. This is going to be a talk on the threads of C# through the years. I am Kevin. Real quick, just a little bit of housekeeping for anybody interested. So the user group meets first Tuesday every other month. So I don't know what date that puts us on, but add 2 months and find the first Tuesday, and you will find the right place. However, if people are interested, IntelliTect is putting on a GitHub Copilot Bootcamp. So this is a half-day event, June 19th, to be able to go through and learn how to use GitHub Copilot effectively, especially with all of the new announcements. If anybody watched Microsoft Build, Agent Mode, there's all kinds of cool stuff. We'll see if we can throw workspaces in there as well. It is a national event, so if you look online, you will see Microsoft promoting it. There's GitHub Copilot bootcamps all over. So if the timing doesn't work, you can probably find a virtual one that does to be able to go through and do that as well. Is that good? Did I miss any announcements? I'm getting a thumbs up. So we are going to rock and roll. So C# is one of my favorite topics. It is by far my favorite language, and it has been my bread and butter effectively my entire career. Now, the best place to start is all the way at the very beginning. So 1996, Anders Hillesberg, who is the older gentleman, middle picture, next to some weird guy who cornered him, Microsoft, and started working on Java of all languages. Now, unfortunately for Microsoft, there was a lawsuit that started up with Sun Microsystems. They went back and forth. It took them years to finally resolve it. But the end result of that is it convinced Microsoft that building all of their stuff on someone else's programming language was probably not a good idea. And so at that point, they decided, you know what? We need to actually break out and do our own thing. And so Anders and team started with the first version dropping in January of 2002. The gentleman on the far right is another name that is worth knowing, Mads Torgensen. He is currently the lead of the C#, as Anders has moved on to TypeScript, which I think is his 4th major language. And then Jared Parsons is one of the senior members of the C# team. So I just littered pictures of me with them because I could. OK, so this is our timeline where we're going to start. Obviously, way back in BC, before C#, those were dark times. We don't remember those. We pretend like they don't exist. But January 2002, C# 1.0 launches with .NET Framework 1.0 and Visual Studio .NET 2002. I don't know if people even remember that far back in some cases. This was even before I started touching it. But then, shortly after, we have C# 1.2 and Visual Studio .NET 2003. That was the first version I touched. So if that gives you an idea of age. If we jump over here, we are actually going to run through over 2 decades worth of C# in just under an hour is my goal. We'll see how well I do. But I am cheating a little bit. So I am running the latest version of .NET. I've got .NET 10 installed, which doesn't release till November. So I'm going to run preview bits and an old C# language. So I've got lang version 1, which means effectively I've got language version syntax from 1. But I've technically got access to things in the base class library, the BCL, from .NET 10. So we'll just not step out. And I am also cheating and using the newer C# format because I couldn't bring myself to use the old one. It hurt me a little too much. But the C# that we see in C# 1 is effectively the C# that we all kind of expect. It doesn't differ that much, at least in its intent. It started off trying to be very similar to Java, and I think it achieved it. When I first went to it, I had an experience in VB.NET and Java, and so coming to C# didn't feel that different. We've got delegates, classes, statics, we've got fields, we've got properties, and I think some people are probably already kind of noticing that some of the syntax feels very verbose, and we don't like typing it. Don't worry, we fix it soon. C# 1.1 just added some stuff that most people don't care about, disposables in enumerators and other things, but that is not necessarily a big thing. So then we jump forward a little bit. We get to .NET Framework 2.0, Visual Studio 2005, .NET Framework 3.0. And this is the part where it's worth noting the difference between the framework, the language version, and the runtime. So the language version for C# is what language syntax are you allowed to type in? What does your compiler know about? The framework is your underlying classes that you have access to. So you'll note I very cleverly avoided list in the last example because list didn't exist back then. All we had was array list. And so when you have different frameworks, that gives you access to more capabilities. And so with 2.0 and 3.0, a lot of these additions are bringing in newer classes, newer functionality that you could go then and reference. Whereas the runtime then is what's going to take that compiled output and then actually run it. For people familiar with the Java and the JVM, this works very similar. C# compiles down to an intermediate language, and then the runtime takes that and goes through and executes on it. OK, so C# 2.0. See how quick we can get through these? Right? So big thing here that we come through and get is we now get generics. Right? The whole joke of the rise of T, because in C# all of our generic parameters are named with T. Austin, welcome. For those online, Austin walked in. We all wave to Austin and say hi. Have a cookie. They're great. For you online, you're missing out on cookies. But C# 2, we end up picking up generics, which is a big update for a lot of stuff. Because before, all we had was array list and non-type things. So anytime you wanted to do a collection of things, you had to effectively cast on your way in, cast on your way out, and you ran the risk of runtime's exceptions. This was kind of that first step of pushing things further left to say, let's have the compiler, I don't know, check types to make sure that I don't shove an object into a list of int. That sounds dumb. This is a compiled language. We don't need things done dynamically at runtime. We bring these ones in. The other big change that came is the idea of nullable value types, the question mark after the int. Prior to that, if you wanted to have a nullable int, that was a separate state flag you had to manage on your own. So just the idea of being able to have nullable value types was a brand new feature. Same with this whole for each concept. Right? Before that, we were back in the old C-style for loops and that sort of thing. And we also, because now that we have null, we now have a null coalescing operator, which is wonderful. And then finally, this little partial types, because we have a program class. And if I click on the right thing, we can see that it comes across and lets us actually do a yield return with an enumerable, let's try that word again, enumerable set of values, where I can just send one item back at a time. Now, this partial class feature is something that gets used a lot later in C#. But this is a theme that you're going to see throughout this, is the C# team is very good at forward thinking. They absolutely abhor breaking backwards compatibility, and so they always try to make sure that C# has this common thread and theme through all of the releases. And so you're going to see features stack on top of each other. Partial classes, way back in C# 2, were not overly useful. Most of the time, breaking up your class across multiple files didn't serve a great purpose. However, we'll get forward into source generators, and then that changes very quickly. OK, now we jump forward, 2007. I'm 2 decades of current, so that's exciting. And we get C# 3, Visual Studio 2008, and .NET Framework 3.5 SP1. The shocking thing, in 2007, Net Framework 3.5, this is still supported today. This is still within support, which is absolutely shocking to me. The reason is Net Framework, its support is tied to the version of Windows that it's released with and that is supported. So we've got Windows Server versions that are still within support that have Net 3.5 with Service Pack 1, all these asterisks, I'll be very exact in my verbiage, that are still using this as a component, and so it will continue to be supported. If anyone is running Net Framework 3.5, please, let's talk. Let's get you upgraded to something that resembles the last decade. That's all I ask. 1 decade back. Is it that much to ask? OK, so 3.0, we jump in. And this is where we start getting to have a lot of that nicer syntax. So before, you saw that we had a property, and we had to have a backing field, and all of this extra typing. And so the C# team quickly realized, we don't like being overly verbose. Developers don't like to type. Developers are notorious for being lazy. And a good developer is a lazy developer. And so we end up with these auto properties. So for my phone box, the phone box has a number. And now I just have a regular get set. Right? I no longer have to have a hacking field, implement all of this stuff. The compiler can go through and generate that. But the flagship feature of 3.0 was link. Link was a very big deal for C# because it took the way that we manipulate collections and arrays and similar things. Iterating over an array is way too common. And it said, you know what? It would be much nicer if we had something where we could project the array, filter the array, flatten the array, do whatever we wanted with it. In this case, we're going to get all of the phone boxes who are in our local area code and just select those numbers out. But they took it a step further. Rather than just adding these extra methods to be able to do this work, they said, you know what we really need is query syntax, right? And thank you, SQL guys. You didn't do a great job. We don't like SQL. This weird select from where ordering is just messed up. We're going to do it in what we think is the right order, where we start with our collection, pull out the item, what we want. Do it in the order that makes slightly more sense rather than in the SQL-y way. The big advantage with both of these is even though those both look like code, and in fact are code, these brought in the idea of expressions, the idea of meta-level programming, where you can actually inspect the code and do something with it beyond just execute. And so things like advantage of this and said, well, wait a minute. If you can write code like that and I can inspect it, I can convert that code into SQL statements, and I can now use C# code, strongly typed C# code, to go through and query a database, which is exactly what they did. The other nice thing that's hidden up here is this idea of collection and object initializers, these curly braces right after the list. So both of these are like, you know what? Newing up an object and then going through and either setting properties or adding items to a collection, that's way too common. Let's give ourselves a nice little feature there. Let's see. OK, C# 4.0 duck type. Does anyone have any idea what the flagship feature was in 4.0? Going once? I'm going to go out on a limb. For people online, everybody in the audience has long gray beards and long curly hair and ponytails. What? Pattern matching? No, you are way too early. Way too early. No, duck type was your clue. I should have brought my duck up here with me. So the feature that actually changed the way people write code is the idea of being able to have named arguments and optional arguments to be able to pass things in. Now, obviously, neither one of these parameters are being used, so they're kind of, we'll call them extra flavor to be on here. But being able to have these idea of optional parameters that you pass in. The bigger change that came through for C# was the idea of dynamic. So I mentioned earlier the idea of the common language runtime, the thing that takes your intermediate language and then goes and executes it. Well, with C# 4.0, we got the DLR, the dynamic language runtime, which says, rather than having the compiler generate the IL, what if we actually do that at runtime rather than at compile time? So in this case, by going through and using the magical dynamic keyword, it says, you know what? Normally, the compiler would try to figure out which of these print methods it needs to invoke, which overload at compile time. By putting the word dynamic in front of it, it says, you know what? Rather than doing it at compile time, let's do it at runtime instead. So you can actually take a collection of objects, and at runtime, it will go through and figure out which of these overloads is the best match. Same rules as what the compiler would have done at compile time. And as long as the runtime type finds a good match, it'll invoke the method. If it doesn't, you get an exception, and that's horrible. But this is one of the few usage of dynamic that's still valuable today. Back when this was done, there was a lot of interop, COM-related functionality where that was useful. Nowadays, we don't do it as much. But this kind of jump table type behavior of being able to push it off is still a valuable trick at different times, whereas some people would just fall back and say, you know what? I'm going to write a switch statement, and it's going to have a lot of cases in it. Don't do that. This is, I think, one of my tricks with dynamic that, because it makes their head hurt a little bit when they, your tooling cannot tell you which overload is going to be invoked at runtime until it actually gets there. It's also a great source of bugs. So if you unit test, unit test, unit test, because it will bite you. It will absolutely bite you. OK, C# 5. What just happened? right? This is the other one. So on all of these versions, you'll note that there's a fairly big delay between each of these in terms of years and months that are going through. C# is shipping with .NET Framework, which is going part of Visual Studio. These are big monolithic things. We don't just turn the ship very quickly and agilely. These things were going along, so the C# team had much more time to kind of focus on bigger picture, big features, and they went after biggest. I'm guessing most can guess this one from my hint. Async and await. Yes, yes. This one. This one here, even though there wasn't, in terms of number, that many features, this was absolutely the biggest one. Being able to go through and write asynchronous code in a very synchronous fashion. So with the 5 little letters of async up here, it instructs the compiler to say, you know what? This is not going to be a normal method. Because when you do asynchronous code, you have a block of stuff that you want to go do. And then when it finishes, you've got some other stuff that you want to do. And a lot of languages, you get promises and similar object structures. And you end up chaining those things together. With async and await, you get that same functionality. But the compiler now does all of the heavy lifting for you. So it breaks your method up based on where it sees those await keywords and knows, OK, this comes first, then this, then this, then this. And it will deal with all of those callbacks. Rather than a promise class, we got this lovely little task class that it would end up wrapping everything in. And it gave us a nice, simple way of saying, you know what? This is now asynchronous code. And everything that came along with this. Because even though the language supported it, the BCL and .NET Framework had to have the task type. It had to have all of those other features that went along with it. But it gets better. But wait, there's more. OK, and then we go into a period of a little bit of quietness, which was a blessing and a curse, right? So C#5 drops, Visual Studio 2012 is awesome. Everybody's using it. We get some .NET Framework releases, and shockingly, there's a huge number of people still running those particular .NET Framework versions. I talked to a bunch of them a few weeks ago. And then November of 2014, .NET Conf. And Microsoft decides, you know what? We are going to place a very big bet on where we think this is going to go and what's going to make C# better in the long run. Right? So .NET Conf, the big announcement, C# was going open source. Right? And this was specifically at the time the Roslyn compiler, which was the C# compiler. Microsoft says, OK, we believe going open source, building C# in the open with community feedback, this is the way the language is going to improve and go. There was a secondary objective in there, or primary, depends on who you want to ask, of this is what it's going to take to make C# go cross-platform. Because .NET Framework, Windows only. And Microsoft quickly realized, you know what? Shockingly, most of the internet doesn't run on Windows servers. It runs on Linux servers. If we don't actually adapt, we are always going to be seen as this language and framework that is Windows only. We are good for Windows desktop apps, and as soon as you get on a Mac, well, we don't care about you. As soon as you want to run on Linux, we don't care about you. And they're like, no, we believe that actually going cross-platform, working in the open, because that's where those devs already are, is the best course of action for the language. So they placed a bet on open source and said, let's do it. And so then we go ahead and move a little bit forward. And you can see open source announcement is 2014. And we get to July 2015. We get C#6, .NET Framework 4.6. Now, there was not enough time between announcement and release. Like, they weren't going to get there already, right? This was the announcement of where we're going. We're not quite there yet, right? So the C# team still has to build stuff, because that's what developers do, right? So we come in here, and the nice part, like that long period of quiet time wasn't necessarily because they were going slow, it's because they were building stuff. So right at the beginning of what we have. So before we had to do console write line, and there's quite often situations where you've got a static class like console, and you say, you know what, I'd like to just use those members immediately in my code. Great. We can pull that in, and now I can reference the write line method without needing to do console write line everywhere. Right? See previous user group talks where I show how to use this to make your code unreadable? That's a different story. The other big one that changed kind of fundamentally the way everybody wrote code was string interpolation, this little $sign right up here at the beginning of our string. So before, if you were watching, you saw the curly brace is 0, and you do string format calls, and they were a major pain. Heaven forbid you've got 12 parameters, and you go, ooh, I need to put one more right in the middle. No, 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 no. One does not simply add a parameter to a string format call. Once we got string interpolation, this one quickly started changing everybody's code base. You don't do string format calls hardly ever anymore. Localization or some other reason where the source of your data is from external, maybe. But other than that, string format largely died in favor of interpolation. We also then picked up, because we have to deal with null, is the P colon, or Elvis operator, as some people call it, to be able to say, hey, P is null, don't do the thing on the right of the dot. Right? It's basically a very quick short circuit to say, let's go ahead. If P is null, we're not going to even evaluate name. We're just going to return null and let that expression populate all the way across. And then the null coalescing operator, way back from C#2, comes into play and puts in a name. So it let us break apart from having to do if this thing is null, if then this thing is null, if this thing is null, because that was really bloody annoying, to just doing question mark dot, question mark dot, question mark dot. Let us collapse a whole bunch of code. And again, we are lazy. We don't like typing. Question mark, one character. I like that a lot more. Down here, because auto properties were then incredibly popular for everything, being able to initialize them straight in line was a nice little perk. And then because methods often were, especially single line methods, were open curly brace, return the thing, close curly brace. 3 lines. It's a lot of typing, way too much typing, especially for a lazy person. So we got expression-bodied members, the idea of being able to say, I'm going to take that lambda, the same thing that I'm used to kind of writing these inline syntax things in my link queries, and I'm just going to use that as the body of my method to be able to say, let's return that back out. And then finally, name of. Now, for some reason, this feature, when it released, I don't know why, it confused so many people. It's very simple. The thing in the parens, the compiler puts that literal string into your code for you. That's it. It is not magical at all. The big advantage, though, is if you do any sort of refactoring tools, because the compiler now knows that that literal string is tied to some identifier in your code, the refactoring automatically applies, and everything goes through nicely. OK. OK, and now we get into the really, really fun areas. We finally get to 2016, and Net Core 1.0 releases. And we get a beautiful example of Microsoft's lack of naming and how horrible their naming scheme is. So we've got Net Framework, and they're like, well, we've got this new cross-platform version of .NET. I know, we're going to call it .NET Core. You'll note I didn't even bother to put Net Standard up there because, dear heavens, that's not even worth the discussion. We figured, let's just keep adding things to the word .NET because that will really help our SEO. So we get Net Core 1.0 and 1.1, which is the very first release of cross-platform. Microsoft starts taking as many APIs framework as they can, figures minimum set of those APIs is that they can actually put in and ship, and that's what becomes Net Core 1.0. Right? When it comes out, it's a little lacking. It doesn't have as much as we would hope or expect, because at this point, .NET Framework was huge, and putting the whole thing in one big bang was not going to happen. So they're like, well, we'll just incrementally walk through this. There's also a way of going through and pushing it, but you'll note the updates to .NET Framework start to slow down as Microsoft shifts a lot of their effort into .NET Core and being able to push things out. And then we pick up C#7. Boy, that train is nice and loud. I love it. OK, so .NET 7. C#7, add that to the confusion. C# versions, .NET versions, the numbers don't match. If that bothers anybody, yeah, it bothers me too. It's really, really, really annoying. One of the nice ones is we picked up local functions. Especially in a lot of algorithm stuff, you're writing a sort function or similar, you have a function that really should only be called by one other function. Right? You put it as a private function in your class and call it, but that kind of leaves it open for when your coworker comes up behind you and goes, ooh, function, I call function. No, stop it. Don't call that one. That one's not for you. So the idea of being able to just put things inside. You'll also note that the local functions we're able to capture on outer scope. So even though A and B are declared outside of these functions are able to actually reference variables outside of them. This is also a great way to shoot yourself in the foot. For anyone who wants to know, ask Victor. He's got a really fun brain teaser of when this goes awry. The other big change to the language is we picked up tuples. Now, prior to this, C# and the BCL did have system.tuple, which if the C# team could go back, I don't think they would have introduced system.tuple ever. Because they realized that they really wanted these lightweight container objects to be able to hold multiple things and bring them together, right? Which is what value tuple ended up being. The problem is they can't break backwards compatibility, so system.tuple is going to live forever, effectively. And what we got instead was value tuple, right? Which is what you get when you put two parens around things with, you know, a little comma in the middle. And more importantly, you can now name the members of the value tuple and then be able to reference them further down, right? So here we have tuple.sum, tuple.product. Huzzah! Even though there are also technically item 1 is a valid thing because functionally value tuple only has one item. But the compiler goes, you know what? You've given me a name. I've got you. Let me go through and just replace those calls for you. The other thing with value tuple came a whole slew of features. And one of the big ones was deconstruction. So we have constructors, we have destructors, and we have deconstructors because, again, the naming's wonderful. But with deconstructors, we can take a single object and break it apart into its constituent parts. So for a value tuple with arity 2, I'm an engineer, I'll be exact, we can break apart this tuple into two local variables called sum and prod, and then you'll note we can reference sum and prod as though they were individual local variables. This was incredibly powerful, especially when you start thinking about things like for each loops, where it's, I want a for each, but I want to have two linked variables. I'm iterating over a collection of key value pairs, hypothetically, from a dictionary, hypothetically. And I would like both of those individual values for the key and the value to be available inside my for each. Deconstruction now gives us that ability to do that, which was awesome. The other big feature, and arguably the one that stole the show, was pattern matching, right? So prior to this, there was this common issue where you'd get an object, and you'd say, ooh, I want to check if the object is insert type here, right? Int, string, what have you. And so you would check if the object was of that type. If it was, you would go through and you would then cast it to that type. And then you take the result of that cast and say, ah, OK, now I'm going to act on that object. 3 operations that you would end up doing in most cases. Pattern matching collapses all of that into one. So the is keyword that we have here says, OK, what I'm going to do is I'm going to check if object is an int. If it is, I'm going to then create a local variable named x, and I'm going to assign that casted int value into x. And then this entire expression is going to return true. So I can now do the declaration of x, the typecast of object, and the assignment of that typecast into x all in a single statement, which is great. Unless you're somebody new to C# and this syntax confuses the daylights out of you, we can cram all of that into a couple characters, which is even better. And then we can act on x and check it for greater than 0 or similar. And since we got the is expression, they figured, well, why don't we just do switches as well? Because a normal switch statement, you just get a bunch of cases of if it's 1, if 2, et cetera, all the way down. But what if we could take this switch and say, well, my case statements, I want to do the same type of pattern matching. I want to be able to say, if prod is an int, let's go ahead and assign it to I, do some stuff with I, and now I is available to me inside of my switch statement to be able to go through and access and use, which is absolutely amazing. This whole idea of pattern matching, you will note in the next several versions, it's going to be a wonderful whack-a-mole game of guess which pattern we're adding in this version. And I think that's going to continue for a decade or more, which will be very exciting. Let's see here. There we go. OK. And now, at this point, with .NET Core coming out, Microsoft is then able to take and break C# away from its bonds and not always be forced to ship it with .NET Framework and Visual Studio. They were able to then start shipping it independently
because you needed to be able to have these .NET Core releases and .NET Framework. And so once it was no longer coupled to Visual Studio and .NET Framework, they said, well, shoot, we just released 7.0. What if we do a whole bunch of point releases with little features and just rapid fire C#? If you are hypothetically trying to write a book on C# and Microsoft starts doing this, it makes it very, very difficult to keep up with updates. Because they said, you know what, we've got all of these kind of smaller features that we've wanted to do for a while. Let's just go through and add them all in. And of course, .NET Framework continues doing stuff all along the way. Well, let's see here. So 7x, because darn it, I put them all one after the other. I was not going to break up all of these. Because again, a lot of these are very small quality of life features. So way back when we got the task parallel library, TPL, with async and await, you saw that I had to write a main method, and then I had to wrap a call into an async method because main is always static void main. No exceptions. That is where it was for the dawn of time. They weren't changing up the runtime or anything to fix that. They're like, but you know what? Everybody wraps the async main in a regular main, and they all do it the exact same way. What if we just had the compiler do it for you? Or in this case, the SDK do it for you. So they're like, you know what? We're going to go ahead and give you asynchronous main calls, which is great. It's like, huzzah, finally, I can now go ahead and make my main async, because async is like a virus to your code. Once you start putting it in one place, it goes async all the way down. Or more accurately, you put it at the bottom, and then it goes all the way up, and everything above that one call becomes async, which is great. The other one that they threw in, just for kicks and giggles, was the idea of the default literal expressions. Normally with default, you would end up having to type, default of string, and the compiler would go, ooh, I know, the default of string is null. And it would replace default of string with null. But then that became, why don't I just type null? Right? One's 4 characters, one's really, really long. But we have a nice default, which especially with generics makes life a lot nicer. To say, go ahead and put this in. But more importantly, it showed the idea of being able to say, you know what? If the compiler can infer the right thing on the right from the thing on the left, let the compiler just go ahead and plug it in for me. Right? And we're going to see several features where the compiler continues to kind of have that same idea flowing back through it. Down here in 7.2, one of the big features was this idea of private protected. So you'll note on all of my samples, I have conveniently left off all of my access modifiers in the interest of brevity. But one of my favorite things to do with my teammates is tell them that if they leave their access modifiers off, I get to quiz them on what the defaults are. Here's a hint. They aren't all the same. A couple of people are smiling. They know I've done this to them. But with most of the access modifiers, we had things like internal, meaning it can only be accessed by things inside of the same assembly. We had protected, which says you can only be accessed by a derived type. So you must derive from me in order to be able to access, right? And regardless of what assembly you're in. We had protected internal, which said you're either in the same assembly or you derive from me. But the problem is there was that or, and there was never an and case to say, I only want to be able to be accessed by derived classes that are in the same assembly, which is what private protected ultimately gave us. I didn't bother to spin a separate assembly to prove it, but feel free to double check. For 7.3, we got value tuples because they were the new hotness and everybody loved them. Having them work with double equals because that's what everyone expected to do. If I've got 2 tuples that both contain the same values, if I do equals equals between them, prior to 7.3, that didn't actually have comparison operators. So now we can actually do double equals between our value tuples, and they compared for equality. And then finally, we get this generic constraint. Since C# 2.0, we had various constraints that we could specify on our T's to say, OK, you can only call this method if your T is a class, if your T is a struct, and various other things, or if your T is a class and implements interface Y, right? Or IY, I guess, if you want to be C#y on it. But there was no way to force a generic constraint to be tied just down to an enum. So a lot of people had written functions that were like, hey, if I put a description attribute on this enum, I want to pull this off. And you wanted to have that method be tied to just enums. You didn't want people to be able to pass in ints or any other random structure type. And so most of the time they just constrain it to struct because that was the closest they could get, and then they do a type check inside, but that means that the runtime is now doing that check rather than the compiler doing it, which is what you expect. Right? So the C# team's like, that's stupid, we got you. And so now you can do that, which is very convenient, especially if you want to show the day of the week, which I'm sure is what we all end up doing, especially on weekends. OK, and now we get here. Does anybody know the name Sertoni Hoare? Does that name ring a bell? No? OK. Titan in computer science, working on a programming language, and he made potentially one of the worst inventions for our entire profession. He invented null. And later on in an interview in 2009, he called it a $1 billion mistake. And most people agree he vastly underestimated that number, that it is probably significantly higher. The number of issues and outages that have been caused by null reference exceptions is incredibly high, insanely high. It is absolutely ridiculous. And so Microsoft finally decided, because C# has had null this whole time, because at the time it was invented, that is what Java had. That was the semantics around C and similar of all of those early languages, and so it made sense. They were trying to have that nice adoption, have it feel familiar. But unfortunately, it then also meant that C# had the same problem as everyone else in that null reference was far the most common. That's why we got the null propagation operator, the null coalescing operator, all of these ways to try to deal with null because it was that big of a pain in the neck. So C#8 comes, and they go, you know what? We're changing this. And so inside of my CS project, I have now made one small change. I have turned on nullable enable. The feature here is called nullable reference types, which sounds weird. I just showed string being set to null. String is a reference type. It was already nullable. Nullable reference types is the idea that you can now decorate reference types with notations to be able to tell the compiler this thing may be null, right? The thing is, this is compiler syntactic sugar. It changes nothing about the execution of the code. The compiler now gets to be picky and say, wait a minute, you told me this was non-nullable. You're trying to assign something that might be null. Bad programmer, you need to null check this, right? And so unlike value types where it actually changes the underlying type, this is syntactic sugar on top of reference types. But the number of null references this has saved me is very, very high. For new projects, because Microsoft, again, will not break back compat, there's too many large code bases out there to do that. That's why it's an opt-in feature, because they couldn't turn it on by default because of backwards compatibility. And so if you opt in, you can now go through and decorate it. And so if you do something of this nature, assuming my language service wants to actually run, which it may or may not, we'll see, you will end up getting squiggles where it says, hang on, you told me string is non-nullable, but you are now trying to assign null to it. And you'll note, it still allows me to check it for null, right? Which is the other operator, the null coalescing assignment. Because just being able to do null, they said, you know what would be really nice is if we could actually null coalesce the assignment. So if message is null, go ahead and do the assignment on the right. Very simple and straightforward to be able to go through and do. Great. The other thing we picked up was a little bit of feature envy from some other languages, Python, of being able to index or pull or splice collections apart. So being able to say, you know what, I'd really like to grab just the last number out of this collection. Or you know what I really want is everything from the second item to the second from last item, right? Trim off the two ends as their spaces or whatever we want them to be. And so just being able to get those indexers and range operators coming in kind of brought C# up to parity with some other languages. You'll note sometimes C# leads the way with async and await. Sometimes it gets feature envy with the languages and decides to play catch up. The other thing, because obviously now the thing is what new pattern matching feature can we add to the language on this release, we pick up property pattern matching, which is what you see with these two curly braces. So before we had is and then a type, but quite often what you want to do is not necessarily cast the object, but check if the object is null. And so the curly braces say, OK, if shape is not null and it has a property edges that is equal to 0, then this expression returns true, right? You can go a step the same kind of declaration assignment that we had before, where we can pattern match into a variable to use later if you want it. The other thing that this enabled, and I don't know how much it was intended from the beginning, but it is quite common to see code like this in modern code bases, where it leverages the C# property pattern match as a null check. Because double curly brace, the programmer's fingers are already kind of wired to find those curly braces on the keyboard. But double curly brace says match all objects that are non-null. And I don't care what the properties are. So you leave off the properties, and it becomes a very simple null check. And so this is not an uncommon pattern to see, especially with a variable declaration, just to be able to say it. Copilot, you need to shut up and stop helping me. Because one pattern match feature wasn't enough, they said, you know what? Let's do switch expressions. Not switch statements. Those are different, right? Switch expressions. So the value goes to the beginning of the switch rather than later on. And rather than having case statements, what we have is patterns, which means we can leverage all the other patterns we've already gotten. Patterns down here followed by a lambda. And the big difference here is switch statements have cases with blocks of code in them, whereas switch expressions must be an expression and must return a value, right? So in this case, console write needs something to write. And so every possible value that goes through the switch expression has to return a value, which is why we see the little underscore down here, which has become the discard character, or in this case, the else block or default block, depending on which way you want to think about it. But with each of these, you can then pattern match, and then more importantly, the right-hand side of the lambda could continue to be more expressions. And so once again, you can chain your code together to make it as unreadable as you would like. The last big one was the idea of asynchronous streams. So we had the for each, iterating over collections, grab me the next item, grab me the next item, grab me the next item. But in a lot of cases, the grab me the next item is a long call. You can imagine having like a database cursor open where move next says, get me the next row out of this database table. Well, we didn't have an easy way of saying, well, I've got async and await. I want to do something asynchronous, like get me the next row out of the database table, and then run this code, but I had no way of really doing that. Asynchronous streams allow us to put the await in front of the for each, and then once again, do that iteration over each of those items in an asynchronous way, where grab me the next item may go out to a database, a web service, what have you, do some work, give you back that result, and then you can continue inside of the for each without having to jump through a bunch of gymnastics to make all of that happen. Whew. OK. See this? November 2020. I would ask people if they remember what happened in November of 2020, but I'm guessing most people don't say C#. But we also got .NET 5, which was kind of cool, and a remote .NET Conf, which was also cool. This was the great unification day. And for everyone not laughing, you all need to go watch the old Firefly series. For .NET Core and .NET Framework, there was always this kind of naming thing where people are like, oh, are you core? Are you cross-platform? Are you framework? And Microsoft finally said, you know what? Enough is enough. There is not going to be two .NETs. We're not going to have framework and core. We're not going to have net standard core, all of that stuff. There will be one .NET, and it will be just .NET 5. And of course, they skipped 4 because they didn't want to call it .NET 4 and get really confused with .NET Framework 4.5, 4.6, et cetera, that were already out there and cause who knows how much confusion was already going to be on there. So now, in modern .NET, all we have is .NET. There isn't core, there isn't framework. I mean, there still is framework because it's supported. But for anything modern, it is just .NET and .NET 5. OK. The other big thing that they ended up doing actually set their release cadence and said, you know what, with all modern versions of .NET, we're kind of liking this November thing at .NET Conf every time. What if we just release every November? So you'll note there's a pattern now to the dates that you're going to see come up. So I like to call it Geek Christmas or early Christmas, because every year just prior to Christmas, I get a new version of .NET and C# to play with. It's wonderful. I get very excited. And then Christmas happens. So both of those things are there. So for .NET 9, it got very different very fast. You'll note something immediately different right at the beginning. I just have C# right at the beginning of my file. None of this namespace stuff, all of that things. Microsoft realized, you know what? Every time somebody does a new project, they are going through, they're typing their namespace, they're creating a program class, they're writing a main, and then they actually start doing the real code. What if we just started with the real code and ditched all that extra boilerplate, which is what top-level statements end up giving you. This whole idea that we can say, you know what? If all I want to do is write that real code, I can just have a top-level statement, let the tooling go through and wrap it up in that main method for me so that I don't have to think about it, and now we're off to the races. And especially for very simple console apps, this works well. But you'll even see this leveraged in newer versions of like ASP.NET and Aspire templates, where the startup code for your app, they just put in a top-level statement. Because why? Like the program class isn't buying you a lot of value, so they end up just giving it to you like that. And then their testing tooling doesn't support it, so you put it back. Sorry, lost my... The other big thing that we got is this idea of new. So way back, we had var and lots of debates about var and when to use var and when not to use var. One of the things that they switched to be able to go through and change to make this a little bit nicer is they said, well, wait a minute. We've got this thing that we've done before where if the compiler can figure it out from one side, go ahead and apply it to the other. So on the right-hand side of my equals, it says new. But the only way it knows what type new should be is by looking at where that value is being assigned to. So in this case, the left-hand side of the equals. And so it can figure out and say, oh, OK, you're trying to call the person constructor. Now, if you put var there, that doesn't work, unless you do horrible, abusive things. Again, see prior user group talk. But it gave us a nice, simple way to be able to do that assignment. The other thing that we picked up was this idea of a record class down here. And the big thing here is most of the time in C# you have classes, reference types, and they have reference-based semantics. The idea that if you have instances that are different, it doesn't matter if their values are the same, those things are not equal. And if you wanted to make them equal, you had to write a bunch of code to make that happen. You had to override equals, get hash code, et cetera, to be able to properly implement that. That was a pain in the neck. And then heaven forbid you go and add one more member to that class and forget to add it to your equals, and now your whole system falls apart. Record said, you know what? There are times where it is very convenient to be able to have value-based semantics between classes. And why do we need the programmer to write all of that equality stuff? Let's have the compiler just do it for you. So when you declare a record like this, name and age become properties very similar to node, and the compiler generates all the equality stuff. So that two person objects that have the same values are equal regardless of whether they're different instances or not, which is a wonderful thing. The other thing that it did is we picked up this little init keyword on the property. So init says, you know what? Way back, we implemented those object and collection initializers. Those are only ever valid right after instantiating an object, like what we have here. Wouldn't it be great if we only allowed assignment to the property during the constructor or one of those initializer blocks? Because then our objects become immutable. And immutable objects pick up a lot of fun properties like thread safety by default, which is really slick. And so we got records that gave us this nice idea of init, which is what these properties also get generated as. And so records by default become immutable, and you can then do fun things with them. And because it wouldn't be a C# release without saying, what new pattern match can we add this time around? We pick up relational and logical patterns. So you'll see the inequalities here of saying, what if we want to make sure that the person is between 0 and 100, and that will mean that they're alive or mostly dead. Right? For everyone in the room, you should note all of the Princess Bride references all around you. We're going to add one more here as well. OK. OK, then we get to C# 10, and we'll note once again, November, we see Net Framework 4.8.1, which is functionally the last .NET framework we are going to encounter, as well as Net 6. And we get down here and we go, OK, well, let's continue on with what we've done. And there's one thing that has subtly switched here. You'll note I've gone back to putting in a main. And the only reason is to be able to show off the file scope namespace feature. This is one of those features that when it got added, change your code base. There's nice refactorings in your tool. Apply it everywhere. Because in C#, since 1.0, you would do namespace, name, open curly brace, indent everything, close curly brace. And Microsoft said, that is really annoying. having that indentation in front of every single line of code in my file. What if we got rid of that? Because most files don't need to have more than one namespace in them. Most files only ever have one. So if you are like a normal programmer and you only have one, put a semicolon at the end, and you'll watch Visual Studio delete the curly braces and unindent everything for you. It's magical. It's wonderful. Turn it on for all of your code. And save yourself some horizontal space, because it is at a premium. The other thing that we picked up, and it's not obvious from what's here, but we got this implicit usings inside of our CS proj. And there is a feature that generates way down in here that we're going to go just look at, called global using statements. Because the other thing Microsoft found is that there are certain namespaces that you always include. You almost include system. You almost always need a list or an enumerable of some, so you're referencing collections generic. You almost always use link, so I'll shoot. And so the start of your file would typically have huge numbers of using statements. And they said, you know what? What if we could just declare those once for the whole project and not have to have those using statements again? So implicit using generates a bunch of these, but the language feature that actually got added was global using statements. So you can go and make your own files of these and add them and make them be whatever set you want. But if you just want the defaults, you can turn them on. And these are the ones Microsoft said, you know what? These seem to be the most common that everyone uses. We're just going to go ahead and plug all of those things in as well. That's not where I'm going. I'm going there. The other thing is we picked up record structs, very similar to record classes with all of the fanciness that comes from there. And then obviously, because it's a new version of C#, what we needed was yet one more pattern matching feature, because once again, pattern matching is cool. And specifically, they dubbed it the enhanced property pattern match. Because before, we were checking circle is not null, because we've got our property curly braces there. And then it's checking the center property of circle. And within that center property, it's saying, well, if x is positive and y is negative, we're going to go through and output, what coordinate on the graph this is going to be. And before, you'd end up having to property pattern match all the way in with extra properties and curly braces all the way down. And they said, that's kind of dumb. Wouldn't it be great if we could just go dot, stop it, Copilot, you are not helping me today. Right? And be able to go through and do it. So we got enhanced property patterns, which was really cool. Again, small improvements. Okay? And then once again, .NET Conf happens, Geek Christmas. I'm excited. Everyone's going incredibly happy. And we go, oh, sweet. What is the next magical feature? And just like how string interpolation kind of changed the way we dealt with strings, the one area of strings that sucked in C# was the moment you needed to put a new line in. And you said, you know what? I want to go down one more line. That shouldn't be hard, right? Right? No, it sucked. And so Microsoft said, let's go through, let's add raw string literals. Some people will know these as here strings as well, depending on your language of choice. But they said, you know what? We'll go deal with the indentation for you. So we'll auto indent based upon how far you indent the closing three quotes. And by the way, we'll let you go through and do interpolation on it with $signs. But wait, what if you want to do JSON that already has curly braces? Oh, I know. What we'll do is we'll say however many $signs you put at the beginning, that's how many curly braces you need to use for any interpolated values that you want inside of it. Copilot, it would be helpful if you're going to autocomplete, at least put it in the right spot. Stop it. Right? So now we can go through and get all of this fancy stuff. Inside of Visual Studio, you'll also see syntax highlighting if it detects that, ooh, this is a JSON string. It'll actually do JSON string highlighting for you inside of that. VS Code, I don't have the right extension installed, so no worky. And then, because obviously pattern matching, we need the pattern match feature, we pick up because now it's like, well, I've got a collection of things. Wouldn't it be great if I could match on that collection rather than having to iterate and match on individual items? Collection starts with a 1 and ends with a 3, and I don't care what items are in the middle. That is a match. Great. Huzzah. We can now match on collections. And then the other one that kind of threw a wrinkle in everybody's plan is this required keyword. Because that init setter for the property was great because it allowed you to only an initializer. But what if the caller never invoked the initializer? You never got set. And so people ended up having to write all this extra code to say, well, you called my constructor, but you didn't set all these properties that I kind of needed you to set. And so then all those things ended up being moved into constructor parameters and all kinds of things, and it ended up being a mess. So we got the require word to say, no, 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 if you're going to instantiate me, you must call the initializer, and you must set these properties in order for this object to be valid. That way, if you end up skipping it, there's actually easy ways to do it. Plus, you then can use the object initializer syntax rather than just having a constructor with 26 parameters, because nobody wants to look at that. The last one that we picked up was the, and I don't want to call it an access modifier, but file local types. The idea of this class here is only available inside of this file. So at this point, source generators are now new and cool and exciting inside of C#. Source generators allow libraries to go through and augment or add on to your compilation at doing things. And it was very common for source generators to want to generate a class but not actually expose it to you. Right? Like I may need to generate some code, and I need this class because it's an internal data structure. But it wasn't easy to generate that class and say, no, 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 it's only going to live inside of source generator land. It's not exposed to the whole project. So now we get this file local types to be able to say, you know what, this is actually just going to be right here and nowhere else. Huzzah. OK. OK. And then last, we start to slow down a little bit more. And we get C#12, .NET 8, which is the current version of .NET still in support. So anybody who's on .NET 6 or older, this is your chance to. Those November releases come in both LTS and STS, so long-term and short-term. No difference in quality. It's just how long Microsoft puts their seal of approval on it, which means that they expect people on modern.NET to be effectively revving every couple of years, every 3 or 4 years, and not going longer than that, because they didn't want the same problem as .NET Framework, like .NET 3.5, and still having it supported until 2029. All right, so if we go here, C#12. This one, there was effectively 2 big things, right? The idea of being able to build up collections. Because now we got that collection pattern match. Now we need collections to act on, because building those things up with initializers. And so now we can just put items inside of square braces. And I'm assigning this into an array. And so it looks very natural to say 2 square braces. But the thing is, the type on the left doesn't have to be an array. The compiler will look at the type on the left, again, same type of logic that it's done before, and said, oh, that's a list. Oh, that's an enumerable. And it will go ahead and generate an appropriate type for you to match that collection type. So if all you have is a set of thingies, you can put them in square braces. And as long as the compiler can look at the assignment and know what type it's going to, and it's a type that it knows how to handle, you will end up getting the appropriate collection, which is great. The other thing that we got is record types came with that kind of syntax where you could just declare things in one line right at the beginning. And regular classes, you still ended up writing full constructors, which was kind of annoying. Because it's like, records have this nice, really concise syntax. It's pretty. I like that. And they're like, well, what if we just made constructors simpler? Because most constructors take in some values, and they'll just set them up in properties, or maybe they're used in a handful of methods. And so if your constructor is nice and simple, you can leverage what they call their primary constructor, which is just a generated constructor with these 2 values here, which looks remarkably similar to the record syntax that they introduced not 2 versions back. The best part, they said, you know what? We're going to make this behave differently, because that's not going to confuse anybody. With record syntax, those members were properties. With classes, those are fields. And there's no way for you to tell the difference aside from the absence of the word record at the beginning, which is great, which is wonderful. So love the concise syntax, hate the implementation. Recipe for confusion. OK, and now we get into one of the most disappointing Christmases ever. Oh, C#13. This one, unfortunately, ended up being not the magical Christmas that we were hoping for. There was a lot of reasons. Some things got yanked at the end. But we didn't really get that much in C#. It was kind of disappointing. So we got the idea that params could be something other than an array type. Huzzah. which gave us some nice things there. We got a new lock type in the base class, which is more efficient. So if you are locking on arbitrary object types now, switching to lock makes it more efficient. So yay. The biggest thing that most people got in all of this stuff was the idea that it just ran faster, which was great. But unfortunately, that was kind of it. And that is present day. We end on disappointment. No. No, no, no. Because you stuck with me for 2 decades. Now we're going to go into the future, because why not? Right? I've got preview bits, and I will emphasize the .NET team does not guarantee any of these features actually ship until they make it into a shipping release. They have various commitment issues. But if we look at what's in the preview bits, we can have some fun. Right? So you'll note right out the gate, one of the biggest things that you'll see here, right? I don't have a project file. I have program CS. Because who needs project files? Right? Other languages, Python, Rust, Go, they all have this nice idea of I just type cargo, space, file I want to run, poof, we're off to the races, we're running. C# has not had that. But now, and I'm just going to do this, .NET run program CS. Thinking, 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 woohoo, it runs. So we can now automatically just run C# files. Not necessarily a language feature, it's more of an SDK feature, but whatever. It's cool and it shows off and demos well, so it made the cut. In order to be able to do that, we had to be able to specify what C# language version we wanted to use. I don't have a project file. Where do I put my lang version? Right? We now have some fancy new syntax to be able to say, well, right now, you won't need to do this once it releases, because you won't be lang version preview anymore. You'll be current. But for now, we have to be able to set our lang version up to preview. The other cool thing that is coming is right here. Right? P, Elvis operator, or null propagation. But it's not null propagation here. Because unlike before, where it could short circuit and return the value on the right, this is an assignment, not a read. So now we're doing write. And so now we get null conditional assignments. I think Victor asked me not that long ago, hey, why don't we have this? The answer was because the C# team hasn't implemented yet. Wait till November. It's coming, I promise. The other thing that we get down here is this nice middle ground for auto properties. We've had auto properties now for 2 decades. Yeah, question?
Is it okay?
Go, by all means, fire away.
So like the preview is the current version?
Yeah, so preview.net, if you go out to .net, because that's not hard to verbalize, you can find downloads for both the current version, which is going to be C# 13, or you can pull down the preview bits, which is C# 14. And so they are currently on preview 4. Don't quote me on that, I think, as of today. But there's going to be multiple previews. So as long as, 14 preview 4, I guess is the way of saying it. Or .NET 10 preview 4, which comes with C# 14. This is the lovely naming scheme that they have landed us in. But yes, if you want to play with this today, all
we have Samsung 25.
correct, exactly. Yeah, the various phone versioning ones. But yes, if you want to play with this stuff today, you just need to make sure that you are downloading preview.net. But we got this nice contextual keyword for field. So if you want to upgrade from an auto property to a full property, you have to bite it all off and go and declare yourself a field and implement the getter and setter. Now you can just partially go halfway there, right? Because most of the time you would declare a backing field, and the expectation was that backing field was only used inside the property. And you just trusted your teammates to not violate that. And that failed in numerous ways. But now you can say, ha, 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 the field is Copilot generated, you can't touch it anymore, which is great. And then the big one here is, you'll note this person class does not have display name on it. If we scroll down here, this is the big change that is likely to steal the show, is extension methods. So with link, we had those .where, .select methods that came in for being able to implement all of those. And those were extension methods. For C# 14, we can now declare extension blocks, because I have dreamed of having extension properties since we had extension methods. And the C# team said, no, you can't have them. We are going to give you all the extension things, not just extension properties. Because inside of this extension block, you can declare properties, you can declare methods, you can build out whatever extensions you want because maybe you don't own the type. So in this case, display name is an extension method, just like extension methods exist today. These are syntactic sugar over invoking these methods because functionally, they are still static methods. They're in a static class. You can reference them via that static class if you want to because you need a disambiguator or similar. But they can also have access modifiers on them. You can see here, I've got a hasName property that's only a getter because it's now an expression-bodied member. And I can build these up. The other fun thing that you can do is the GUID class. Like, for example, GUID, new GUID. GUID's a static class. It doesn't make sense to add an instance extension on it because it's static. You expect to be able to just go through and do it. And obviously, the best GUID here is 42, 42, 42, 42, 42. Obviously. For those not laughing, go read Hitchhiker's Guide to the Galaxy. But with the new extension blocks, we can now declare static extensions, which sounds weird since extension methods are inherently already static, but now we can attach them to static types, like GUID, to say, oh, I want to go through and do this. And the only thing that changes is whether you have just a type by itself or a type plus an identifier on that to say whether this is an instance extension or whether this is a static extension. Again, this is all preview, could change at any moment, but there we go. OK, so I want to leave you with the same way the C# language spec starts off in part of its introduction. C# is intended to be a simple, modern, general-purpose, object-oriented programming language. Thank you for coming. I realize I went a little bit over an hour. Dan is raising his hand for.
Yes.
Hit me. Yes.
And so when did that start moving to functional programming, and do you see that happening or continue?
Yeah, so the question was, a lot of the features kind of brought functional programming into C#. When did that start? Do you see that continuing or similar? Especially with the stated purpose here, which has been the same stated purpose since C# 1.0. I'm going to kind of punt a little bit. I think there are a lot of times where functional style lends itself well to a particular problem that you are solving, and C# has brought in as many of those features as they can. Union types is a hotly debated one out on the C# Lang repo if anybody wants to go and see it. And so I think it's reasonable to expect that we will probably continue to get functional style features in the future, but they are probably going to on them because the C# team wants to make sure that C# feels like C#. They're not just going to tack something in willy-nilly here and there. I will also say, for whoever asked the question, if you go out, Mads Torgensen, the gentleman I had the picture of at the beginning, if you look up C#'s functional history, you will probably find a talk that he's given, I think, 3 or 4 times at this point, where he goes through showing various features, and they're probably the ones that stood out there as well, of features in C# that were very much brought in because of a functional. And so because there is that idea of this is useful in the right context, I would say expect more where at least it makes sense. So great. I realize we are over time. Thank you, everyone, for coming. I will hang out if people have questions, comments. Happy to discuss more. This is obviously one of my favorite topics, and I will talk about C# for hours. GitHub Copilot Bootcamp for IntelliTect, if anybody is interested, or next user group 2 months from today, first Tuesday of the month. Thank you very much. Oh.